Right, good afternoon, good morning, good evening, wherever you are. Welcome to my next webinar. Today we're going to talk about avoiding if. For those of you who haven't participated in one of our webinars before, you're very welcome. We're using the Zoom software for the presentation, and the feature of that is if you jiggle your mouse at the top or bottom of the screen, you'll see a little toolbar. And we're running a webinar rather than a web meeting, which means that there's no audio interaction. And so unfortunately, I can't hear you. So as we go through the presentation or at the end, you're very welcome to send in questions. And there should be a tool on your toolbar that allows you to, first of all, raise your hand to draw attention to yourself, and also then to write a question in the chat feature. I'm Jonathan Swan here at Operis. I'm joined by my colleague, Ben Lyon. He's sat over there patiently waiting to answer or respond to any of the questions that you have, and he'll pass them over to me. And so between the two of us, we should be able to interact reasonably well with you. So without further ado, from a very wet and windy and cold November London, we're going to take you into some of the issues about the if function. And one of the key things is that here at Operis, as with many modeling consultancies, we have a reasonably strong view about the use of if, and generally to avoid it where possible. And quite often people are challenged by that because unfortunately it's one of those functions that you tend to learn very early in your Excel training. And bear in mind, most people do get Excel training, but don't tend to get modeling training. We tend to find that they can lock into a small set of functions at an early stage of their career, and they never really push beyond that. And if is quite exciting the first time you come across it, because instead of having linear calculations, A plus B minus C, suddenly you're exposed to the world of branching calculations, where whatever the test condition is, you're then leading off into different directions depending on the outcome of that test condition. And indeed, you can then take it further by having multiple functions, such as and or, to allow you to have multiple test conditions. With and, all the test conditions have to be satisfied, with or, just one or two of them. And that exposes you to all sorts of potentially interesting things to do. But generally, you tend to find the reality is in the sorts of models that we look at here at Operis, that the if is really, as we would class it, it's a stream of consciousness function, where somebody sits down to solve a reasonably intractable problem as they see it to begin with, and they tick off the various bits of the solution by ending up with one monster, usually nested if, and for various reasons they never decide to polish it up, they never decide to review it, and they certainly don't consider simplifying it and considering other alternatives. And the problem is, it's the idea of the alternatives. Are there different ways of approaching these sorts of calculations? I've got a very focused approach today, and I find it quite successful in my training courses. So I do deal with people like you, very intelligent, experienced modelers, who perhaps have never pushed the boundary to consider looking at problems from a slightly different perspective that doesn't necessarily involve the approach of test condition, outcome if true, outcome if false. And so the session then should be about 30 to 40 minutes for this one. We're going to look at the basic division of why we object to if. Firstly, from this formula auditing perspective, flip that over, formula writing perspective, the simple aspect that these if type routines can be quite difficult to interpret, and then to follow through the audit trail back to the precedents to then understand what the test conditions are actually doing, and then of course to validate, is the true outcome always going to be true, and is the false outcome always going to be false? And sometimes there are overlaps when potentially the formula hasn't been written in such a way that they are mutually exclusive. That will be the bulk of the presentation, and I've got a nice little example to take you through for that. The second objection is more technical. And I'll come back to that towards the end of the presentation. It is technical, but it's worth being aware of actually how the if function actually works in Excel. So having noted that, then we'll flick to a little spreadsheet I've got prepared. That should allow you to understand what I'm trying to achieve here. And this is a very simple example I'll give you, but I'm sure you'll appreciate that it's not that uncommon to see this type of questioning being raised. And I'm looking at a very simple debt calculation here, where in the orange cells I've got the loan amount as an input of 10, And the information then that I'm going to start the repayments in year 2 of my forecast period, and there are going to be 8 repayments from that point. And so to manage this, I'm going to insult my intelligence by beginning with some sort of if treatment to solve the problem. So I'm just going to set up what here at Operis we call a corkscrew. So I'm doing senior debt, and the idea of a corkscrew just carries information across time. I have an opening balance or brought forward. I'm going to describe the drawdown. I'm going to calculate in a moment then the repayment, and that leaves me with a closing balance to carry forward. And this is a very simple mechanism. I'm sure you're familiar with this. But if we knock out the easy bits, which is the brought forward, it's just a link to the previous balance. There's no shortcuts or anything for you today, unlike some of my previous seminars. So Ben's sitting back and relaxing, knowing that he doesn't have to keep typing them in. The drawdown then, I'm just going to stick for this example for today, just with a single drawdown then. So we can see there it's going to be 10, and I'm assuming it's going to go in period 1. And I'm not going to bother with anything else in that row. So again, not good modeling practice here, but just typing in some zeros to indicate that. Repayment we'll gloss over for a second, because that's clearly what we're going to try and solve. And then the closing balance is going to be the opening balance plus the drawdown less the repayment. We're not making any repayments, so the 10 will just stay in the balance like that. Now, let's begin with a scenario that we've been on our Excel training. We've learned all about if. We feel bouncing with confidence that if is exactly what we want to do here. Why if to work out the repayment? Well, because there are 2 conditions to when we want to make the repayments. The repayment is simply going to be the loan amount divided by the number of payments. I'll stick to that simple term loan concept there. But the conditionality here is, firstly, we don't need to make any repayments until period 2. And secondly, when we do start the repayments, there will be 8 of them. And clearly both of those are variables. So I need to think carefully how that's going to fit into the spreadsheet. So if I start out with this simple calculation then for the repayment itself, it's going to be the loan amount. I'm pressing F4 here. Ben doesn't need to type that, but F4 puts the dollar signs in to make it absolute. And I divide the 10 by the 8, again pressing F4 to make it absolute. And so, well, you realize it's gone wrong straight away. It's very clear that I'm not thinking properly. I'm starting the repayments immediately, and I'm just carrying on making them, even though by the back end here, the loan has been repaid. So the balance goes negative. So clearly, just the payment formula on its own isn't sufficient. We need the conditionality then to recognize, firstly, when the repayments start, and the second condition is when do they stop, or for how long do you make those payments. So with our knowledge of if at the forefront, we can leap into the calculation here by writing if, and then I'm considering, well, I've got 2 test conditions. So instantly, a touch more complexity of adding in an and I mentioned that in the opening preamble there. And is a function that requires both of its arguments to be true in order for it to return the true. So my first test condition is the start. The second test condition is the stop. So the start is going to be, oh, hang on a sec. The information I've got then about the repayments is expressed in numbers, not as dates. But my periodicity very clearly is described as date-based information. So it's not telling me that they start in 2020 at all. It's just saying it's starting period 2. So the first thing I'm going to do, and again, this is the start of the guide into the simplification process, is I'm going to put in some information here that identifies the number of the year. Now, it would be trivial to simply type in 1, 2, 3, 4, but our approach normally is to try and make sure that during the forecast period, you've only got calculations. So I would do an incremental sequence here by putting a 0 in my base column. Column C I'm describing as base. So I'm taking the C3 there, and I'm simply going to add 1 to it. And that will increment up quite nicely to the end of the forecast period. So what I can now do is relate the periodicity now as numeric to the information about the repayments. And so going back to my starting point, if and you can see just from that quick example that that's how ifs typically evolve. I'm going to do this. Oh, I haven't thought of that, so I've got to do a counter. Then I haven't thought of that, and that's often what happens in real life, and that's why we see these ghastly formulas in front of us. So the first test condition I'm going to suggest would be, when do we start repayments? And that's going to be reasonably easy enough to do, because I've now got a year counter. So we start the repayments and continue the payments once that goes to, well, I'm going to do greater than or equal to the value of 2 that's been entered as the input. And again, a dollar sign around that. So that's my first test condition. Now the second test condition, let's think this one through. I'm going to again use my counter to drive this, but how do I relate it back to the number of repayments? And again, I've deliberately come up with this particular solution. And I'm hoping as I go into this, you're all bouncing up and down your chairs thinking, no, that's not how I would do it. I do it a different way. And again, that's precisely one of the points I want to highlight as I go through this. Basically, whenever the repayments start, there will be 8 repayments to follow. So if it starts in period 2, we would carry this through then to period 10, the final period. And whatever that first number is, if it changes, it will still be 8 repayments unless we change that input as well. So the approach I'm going to do here, and follow me carefully as I do so, is test to see that the counter value is less than, and follow this, I'm going to do brackets, and I'm going to do the 8. Basically, I'm doing an offset. I'm just pushing the whole thing across one. So I'm going to do 8 plus, oops, no, sorry, I shot myself in the foot there. There's a dollar sign again. Right throughout this demonstration, there's dollar signs all over the place. F4 for that, okay? So what that really means then is if I start the payments in period 2, then there'll be 8 subsequent payments. So if I add the 2 together, that's 10. So the repayments will start in period 2 and run through to period 10. And that should work, I hope. And that's the and. I've got the 2 conditions in there, both of which have to be satisfied. If both of them are satisfied, then going back to the if, I'm now going to do the basic calculation for the repayment, which we agreed then was the loan amount divided by the number of repayments. Dollar signs, make sure I get all of those in. And if either of the test conditions fails, then we return 0. And I should find, if I'm really lucky, that it works. And indeed it does. So I've got, as you can see there, 8 equal repayments. And so the debt is completely and exactly paid off. So that's the proof it's working. Further proof, if required, I can start the repayments immediately in period 1. Yep, still doing the same thing. I can defer until period 4, but that goes off beyond the edge of the forecast period, as you can see there. I can change the other input as well, so I can reduce that. It's still working. So it's still absolutely fine. It is robust, and that is, of course, an acceptable solution. I'll just reset the numbers back before I look at the formula again. I built the formula up with you, and by looking at that, if you remember what I've said over the last 5–10 minutes, then hopefully you'd understand that formula and you'd be able to explain it perhaps to a colleague or to a junior and get them to write something similar. But the suggestion I have to you is that if you were to look at this again next week or next month, or give it to somebody who hasn't seen this webinar, that might be a bit of an eyeful in terms of understanding what we're trying to achieve, particularly, as I suggested, the way I've dealt with the number of repayments, part of the calculation there. And that's what we're really about, because so often we see this idea that ifs are written on the fly while you think about the problem, and then you get dropping out, you're editing the formula, you're changing little bits, and eventually it works. And you might run the test to prove that it works, as I just did, but sometimes that doesn't happen. One of my favorite anecdotes, if I can bore you for a moment, is I was working for World Bank out in India, and it's a live project, and it's a hydroelectric project as well. And one of the analysts took the opportunity while I was there to show me a model that he'd set up that dealt with their pricing, and it was live. It was for the electricity distribution and the pricing model they were using at the time. And he had an if that had 5 levels of nesting, and he had happily written that formula, and the first 3 steps through the if actually worked, no problems at all. But he'd never taken it to the next 2, the final 2 steps, and both of them failed. Both of them generated value errors, and those value errors propagated right through the whole model. So you can imagine then that at some point at 3 o'clock in the morning, when they changed over tariffs or something, and suddenly the 5th part of the if was in operation, the model would have collapsed, and that would have been deeply embarrassing. But nobody checked the model, nobody run that level of audit and stress the model sufficiently to generate those outcomes at the end. So that's one of the concerns I have, even though this is a multiple test condition. And so that both of those need to be understood for me to be fully confident this formula is working correctly, despite the fact the formula for the calculation of the repayment is so trivial. It really is. So again, we've proved that it works. It's absolutely fine. But let me take you into how we might approach it here. And this allows us to deal with really complex things, not just 2 test conditions, but multiple test conditions. And it's an approach I hope you may even have seen already, but I'll take you through how we would do it. So on the second sheet, I've got the same information. We've realized the importance of the counter, so I've retained that. So I don't need to repeat the whole thing. Loan amount's the same. Let's start and the repayments, that's all the same as well. And what I'm going to do is reproduce the corkscrew, senior debt, brought forward, drawdown, repayment, and the carry forward. So that's all going to be the same, and I'll just knock that out quickly as well. So quick brought forward opening balance, and the drawdown we'll have still as the 10. I should really have copied that from the other sheet, shouldn't I? That would speed things up. And repayments, we'll calculate in a second. And the carry forward then brought forward plus the drawdown, less the repayment. So much the same way, exactly the same approach so far. But my approach now is to suggest that let's make it more obvious as to when the repayments are happening and why, what's driving the process. And again, I'm sure you'll imagine that for demonstration purposes, I've condensed all of this so it all fits on one screen. So there's the if, all fits on one screen. Here's my version, it's still going to fit on one screen. But you might clearly imagine that this could extend over several hundred rows. It could be derived from information on different sheets and so forth. And so you realize then that this stuff could be way off screen. And so the first thing I'm going to do then is to recognize the simplicity of the repayment formula by writing it all on its own. Annual repayment. And so it's our no-brainer here, which is to take the loan amount and divide it by the 8 installments. So that's the target repayment that we want to use when necessary across the forecast period. Now, the first thing I need to do here is identify when do we start the repayments. When they due to start. No other manipulation. It's just that statement of fact. Is this a point at which the repayments start? So I should do start flag. And I'm going to talk more about this type of language a bit later on, because we're going to do mask in just a moment. So what's the difference between a flag and a mask? Good question to ask. And the start flag then, I'm going to get it to read true at the moment repayments are supposed to start, which is period 2. And it's going to read false at any other time. And I'm going to start my work here by using an if in order for me to show you how we're going to demolish the whole idea. So the test condition with an if would be to look at the year counter again, and is it equal to the starting year value, starting period 2. Again, that needs to be absolute, so I just tap the F4 again. So that's the test condition. So the first thing I do is the outcome if true. Now, what I'm doing now is breaking away from the idea from doing a calculation based on this, just the statement of fact. Is this the start period or not? True or false? So I'm going to go straight in with this with quotes then true and quotes and false. So very clearly one's true, one's false. And that works perfectly. And we can see clearly there's the flag operation. Flag is normally just one cell that returns a particular value. And so at that point there, out of the whole row, that's the flag of the repayments starting date. Okay. Well, that's not really moving your understanding of if forward at all. And so the next step is to take out the quotes from around the text strings I wrote in there for true and false. And I'm sure you've seen this before, but I then learned that true and false are accepted as valid operators in Excel, and they're known as the Boolean operators or the logical operators, and they return false and true as uppercase. And examining my formula using F2, I can read there true and false. Excel converted it. I didn't change the case, Excel did. And so that's showing me that true and false are something special as far as Excel is concerned. But then we rewind the process and say, well, why have we done this? What are we trying to show here? And again, it's that idea of statement of fact. I just need to know when is the start year, which out of all the 10 years there, which one is the start year? There's no action to take. There will be further on, but this level, this one line, there's no action to take. And so that's where we do the first bit of demolishing the if. If there's no action to take, if true, and no action to take if false, then don't bother with the if. And instead, simply invite Excel itself to evaluate your test condition. So I get exactly the same results there, but now I've cut down all of that clutter. So it's a single statement. Is this statement true or false? And we get Excel to evaluate it. And that could be sufficient. But again, I want to take you through a little journey here. So the next thing I'm going to do is we understand that true and false is logic in that sense, but also it has a value. I said logical operator. Logical value is a correct description. True has a value of 1 and false has a value of 0. Now, in many cases, you can live happily with false and true just as they are there. But in other cases, you might need to show them as ones and zeros. As I said, I could easily circumvent this little bit, but I'm going to do it deliberately just to show you how this works. So I'm going to do a start count. I think I'll name this one. And that's going to show the true and false. Instead of being false true as words, it's going to show it as a number. And all I do there is I take the value, the logical value, and I either, there's two ways of doing this, I can either add 0, and that forces or coerces it into a numeric, or the alternative that some people prefer is simply to multiply by 1, and that does exactly the same job. So add 0 or multiply by 1. My own preference is the adding 0 technique, but obviously use whichever one you prefer. Okay. And that gives me the numeric. Now, one of the reasons I've taken it from being the true-false, which would work for many operations, and converting it to number is because of the next couple of steps. I'm going to convert this into a counter, which is part of our overall objective from the exercise. And the way I'm going to convert it into counter is that's the start point, that's the flag. So we're waving the flag, start the repayments at that point. But now I want to have a numeric to represent the rest of the range to show that this is the period of repayments. And so the way I write that is with the 0 in the base column, and I add the previous value to the value above. And what that gives me then is a string of ones once the start flag has been waved. Okay. The next thing is to develop this further into a cumulative counter. I'm just going to call it cumulative there. And what this will do is rather elegant. I'm going to take the previous value and add the value above. Same type of formula as I've just written, but this time I should see an accumulating set of numbers. Okay. Now remember, all of this is driven from the occurrence of that true there, which is based on that number there tested against the year counter. So we're not really offsetting the years in that sense. We're introducing this element, counting off from that point in time. Now what we can then do is use that number sequence and relate it back to our values over here to identify when is the start year and when is the end year or stop year. So I can write this then as a start mask. Now what's that going to be? Well, as I go into this phase, you'll realize that going back to that flag idea, this is when the repayments start. So this must be the period of the first repayment, the second repayment, the third repayment. So my number sequence actually has a more specific meaning now. It's enumerating the repayment itself in the sequence. And so the idea of the mask then is to convert this back into true and false. So I'm going to simply say, is the cumulative value greater than 0? Okay, copy it across. And I start the repayments from this point onwards. So while it says true there, I make repayments. But clearly, if we've identified that there should only be 8 repayments, you can see I would continue to make the repayments beyond the end date. Now, with the AND approach, I bunged it all into one monster formula and just hoped that the whole thing would work out. But in this case, I'm going to make it specific. This is when I start, and now I'm going to have a stop mask. Now, the way that's going to work then, it's going to have false at the end. Okay, this one's got the false at the start, so start the repayments there when it goes to true, but this one's going to read false at the end. And the way I'm going to do that is, again, looking at the counter. Now, how's this one going to work? Well, it's going to be based on the cumulative. And to test then, not the years across the top, of course, but just using the cumulative itself, relating it back to the 8 there. So I'm going to make repayments while the counter, the cumulative counter, is less than or equal to the number of repayments. So is this less than or equal to that? Remembering, of course, to press F4. Don't want to always forget. Copy that across the row. So it begins with true, but ends with false. Okay. Now, what you'll now be able to distinguish from all of this is the period when both lines read true is the period of repayments. So there's no repayment up front because one of the masks is false. There's no repayment at the end because the other mask is reading false. So if we combine the two together, then we get what I would describe as a repayment mask. And that is going to use an AND, because that's what it's for. So only make the payments when both of those are true. So and that, and that. So false, copy across the row, and watch what happens in the final period. There it is, false again. And I've got 8 of these values where it reads true. Okay. Now what that means then is we can come back to our repayments, we've worked out what the trivial repayment formula is. So we're going to use that number, 1.25, and simply, F4, and then multiply it by the repayment mask itself. And I should, if it all works out to plan, there you go, in exactly the same way as before then, I start the repayments in the second period, I complete it, the repayments in the ninth period as it is here, and I've got 0, so I've completely and exactly repaid the debt. Now that then is my new repayment formula, and compare and contrast it back with the original repayment formula. Now again, I do have the pushback here that people find the if approach more intellectually satisfying, because goodness me, look at the real estate I've saved here. I've got the whole solution in one single formula. And that may appeal to some types of mind, but when you're working collaboratively or with colleagues and clients and whatever else, other people are going to look at your work, they might not appreciate your genius in writing a monster formula that solves the whole thing. My approach, yes, it certainly takes up a little bit more space, but I've broken out the logic. You can see exactly what I'm trying to achieve here, the idea of starting and stopping, which wasn't very apparent. Again, if you look at my stop part, if you look at the stop part of the formula, which is this one, that's not immediately apparent as to what that is actually really doing, is it? And that would need a bit of explanation. That's reasonably straightforward, but that doesn't really make sense at all. But in my case, you can read back through each of these, and this is what we teach in our courses. When you're using logic like this, you can do some really clever tricks, but give yourself a favor here. Just break each step into a very simple test. So we now know what an AND does. Two conditions in this case, both of which have to be true, based on a stop mask, which has one test condition, which is based on a start mask with one test condition, and so on as we go back up through the sequence here. Each step should be easy to both read, audit, and to explain to others. Now, another thing I'm not going to demonstrate here, but I'm going to appeal to your understanding of these sorts of things. Clearly, this is the debt service period. And what do we do during the debt service period? We do debt service cover ratio calculations. Now, with my approach here, with the repayment mask, I can now go off and do CFADs divided by debt service multiplied by the repayment mask. So that's reusable. Once I've done it once, I can use it for all sorts of things that are conditional on the repayment period. Can't do it there, can we? If we've got a debt service cover ratio calculation somewhere else in the spreadsheet, it can't use any of this logic. And having started using ifs and ands like that, I'd probably end up seeing a formula where the debt service cover ratio, CFADs divided by debt service, that sort of thing, is again embedded in all of this logic. So we argue strongly for the idea of the masking type approach, not just because of the way I've used it here, but the reusability. So many things will be driven by dates. You might have construction periods and things happening then. You might have operations periods you want to distinguish from construction periods. So set up a mask each time, and then just reuse it in the parts of the model that are relevant. So I'm hoping that will give you some insight into the elegance of this type of approach. It's very simple, easy to inspect. Yes, it takes up a few extra lines, but the logic is there. It's very easy to follow. 2 o'clock in the morning, you're trying to balance a balance sheet and you think there's something going on down here. Well, it's all laid out. Okay, it's all clearly laid out. No complex formulas. Nothing that needs a damp towel across your forehead in a darkened room. This stuff just lends itself to easy inspection. And therefore, if it's that easy to inspect, you can be more confident that it's doing the right thing. I did mention there are other reasons for not using if, and I'll go back to my slideshow to take you through these. So I've dealt with the formula auditing. So that's the idea of just both writing and understanding, reading formulas, reviewing formulas. But the technical one might need a bit more explanation. And there are two elements to this, and they're closely intertwined. So I've got more than one slide all at once. And the first thing I'll do is revert back to school days and remind you of certainly what we're taught in English schools, which is the idea of BODMAS. That's the order of operations, or the rules of arithmetic priority. Over the pond, they call it PEMDAS or PEDMAS. We describe it as brackets, order, division, multiplication. Over in the US, they would say parentheses, exponentiation, and so on. But that's how Excel, that's how mathematicians, scientists, anybody does a calculation. It follows a particular order based on the operation being carried out. So in my example here, I've got a simple if with the test condition there is A greater than B. Now, I don't need to worry about numbers here, it's the principle I'm describing, that's what Excel's doing. It is A greater than B. If it is, do C times D. Otherwise, if it fails, then do E minus F. Now, the question I set to my students is going to be, if we understand BODMAS or PEDMAS, whatever you want to call it, the order of operations, what does Excel do in this formula and in what sequence? Now, intuitively, and again, it goes back to early Excel training, people are invariably taught that you look at the test condition first, and then you do the true outcome or the false outcome, depending on the test. But what we know from BODMAS is that Excel doesn't even look at the test, doesn't even look at the function name to begin with. The very first thing it's going to evaluate is the content of the brackets. So effectively, it's ignoring that, just going straight to the brackets, and then applying these rules. So in fact, intuitively, you'd say, well, I know that this test is true, so do that, and don't do anything with that. That's not what Excel does. Excel, in fact, will look at all three of these. And in fact, in this particular example, the first thing Excel does is it evaluates C times D, just as if it's a formula on its own in the cell. Again, using our order of operations, the second thing it does is the E minus the F. So it's not conditional on the A and B. We haven't got that far yet. It's being instructed by its own internal logic, C times D first, followed by E minus F, and then work out the test condition, and then take the three results that you've evaluated and pass them out to the if. And then if, the algebra of the if function will then use that information to return the true and false, and then to use the appropriate lim of the if as we understand it. Which means then that for any if, Excel is actually doing three pieces of work. Despite the fact intuitively you might think it's only doing two, it's going to do three. And this is a very simple set of examples here. You will know from long experience that these will be very big, complex calculations. Nested ifs follow exactly the same rules. So it go right through the innermost set of brackets first, then work its way back outwards. So there's a huge amount of work involved in any if formula. Huge amount. The other thing then that links directly into this, and again we're on the very technical side of formulas, is this idea of late binding. Now what that means is if I've got a formula such as on the carry forward of my corkscrew back in the spreadsheet there, the brought forward plus the drawdown less the repayment, if you look in column D, you can predict what it's doing. It's the brought forward plus the drawdown less the repayment. So if you look over at not just a column M, but you look at column XFD, which is the furthermost column in Excel, and you saw the same formula, A plus B minus C, you know what it's doing. You can describe it. It's the brought forward plus the drawdown less the repayment. The idea of late binding formulas is, with the conditionality we've introduced here, and if isn't the only example I should emphasize, but what we've now got is that all of these formulas have to be evaluated, and that means if you see this in column D, you have to work out what the answer is going to be. And if you see this over in column XFD or anywhere else, you still can't predict what the answer is going to be because you don't know what the test condition is doing. So that's the conditionality we then see of late binding formulas, is the uncertainty of being able to predict what the result is in any particular cell. And Excel itself doesn't know what the answer is going to be until runtime, as it's called. So these are often called runtime problems. So when you run recalculation, you press F9 or whatever it is, it's only at that point in time that Excel will give you a definitive answer to the current if in that cell. So you can't really predict confidently what it'll do in any circumstance. And again, that's my Indian hydroelectric power station problem, that the formula looks okay in the current circumstances, but has it been tested in all eventualities? And sometimes that's going to be quite hard to actually test all of those potential different outcomes. So late binding then links directly to BODMAS. Poor old Excel, if you've got a couple of lines of ifs in your spreadsheet, Excel's doing quite a bit of computation in order to return the results that you can see. Again, intuition and long experience from having used Excel if for years, you might be misguided into thinking it's a very simple, straightforward formula. There's a lot behind it, and that can cause the difficulties that we know about. Also, I might go into consider, because I've been so rude about if, and there are other solutions as well I haven't mentioned, such as max and min and functions like that. But at Operis, we do actually use if regularly, and people are quite surprised because they think that after doing one of my courses that I've been so rude about it that it doesn't cross our threshold. But it does, and we use it widely for error handling, because the formula either works or it doesn't work. And that's a primary use of if you can guarantee that what you're looking at is binary, it's only ever going to be one of two things. And so in that case then, I've got my example from the debt cover ratio earlier on. The debt service cover ratio formula, CFAS divided by debt service, is lovely in the debt service phase. And again, think about the masks that we've just seen that can help us with that. But the simple fact is, if the debt service is 0, because we've either not drawn down the debt yet, it's the drawdown phase, or it's post-debt service, so not necessarily it's operations phase, it's just the debt's been and gone, then the balance would be 0. And so we would just simply test that. If the debt service, and this is the distinction as well, by the way, because you could use the mask, as I mentioned in here, but our approach to error handling, I would say it's fussy, but we like to state what is the root cause of the error. So I'm going into a slightly different area now, but in this case, the divide by 0 error that would be generated by this, if the debt service is 0, that's the root cause. It's the debt service is 0. There are things like if error and is error and other error handling functions in Excel. They're not as reliable. Well, they are reliable, they will do the job, but particularly with the if error and is error, what error are they actually capturing? If you've set up an if or is error based on the debt service is 0, so you don't want to use the calculation, and then you get something else like a value error generated from a different formula, then the error handling kicks in. So you get a line of NAs in this case, not because debt service is 0, but because there's another class of error happening. So we much prefer to go back to basics and say, well, in this particular formula, what is the root cause of the error? It would be if the debt service is 0. So if you've got a rogue value error from some other formula, then you look at this, you can see that debt service is not 0, so there must be something else going on. So that's our preferred approach. So in this case, they're very clear. If the debt service is 0, don't bother doing anything. So we use the NA expression there to capture that. Obviously, if there is a debt service value, then go ahead and do the calculation. Okay, so that's the real exception at Operis. Error handling, brilliant. If is perfect for that. So I pause at this stage, noting the time. Do we have any questions coming through? Ben, nothing happening? So giving you a quick insight there into the way that we would consider using alternatives to if, with the exception there of the error handling. There are other ways, and hopefully even with the example I've given you with my little Mickey Mouse model there with the debt calculation, you start thinking about not using if, and those masks and similar treatments suddenly open up a different way of thinking, and you can actually solve some really complex formulas very simply just by breaking all those what you consider complexities of the formula, just breaking them into bite-sized chunks, one by one, row by row, and then summation there with an and or an or. You can then capture all the different trues and falses to come up with a result that reflects what was originally a very complex problem, and indeed probably still is a complex problem. But you've broken down the steps, so much easier to see. That sort of approach to writing formulas underpins a lot of our modelling teaching. So I conclude with our standard slide here. You can learn more about not just logical formulas, but many other formulas and functions on our modelling courses. The entry-level course we encourage everyone to attend. First of all is our methodology and techniques, and that's then followed by the extended techniques. Most of the mask work that you've just seen is on the extended techniques course, and we do quite a bit of work using those. We also have, if you're not really a model builder, but you spend your time trying to interpret other people's ifs and other things, we have one of my favorite courses, which is the Assessing and Interrogating Financial Models, which is designed much more from a sort of peer review perspective. So rather than sitting there with a blank spreadsheet, building up a spreadsheet from scratch or model from scratch, we look at the idea then of reviewing a colleague's piece of work or perhaps a consultant's piece of work. We also have the Operis Analysis Kit, which we refer to as OAK. We run a regular monthly webinar on that, and I'm sure Ben will tell you all about it, and he will also be very pleased to tell you about our rapidly expanding webinar program. I'm just doing the work at the moment for the schedule for the first quarter next year. We should have some ideas for that very soon and get something up for you. I'm Jonathan Swan. I tend to run most of these things, but my able colleague Ben then is your point of contact. His email is, as you can see there, blion@operis.com, and that's his phone number. He would be delighted. He's almost poised because he's sat in here and he's ready to go. But he's poised to take your phone calls and emails if you want any further information, not just about what we've covered today and our courses, but of course the other Operis work such as model audit, model review, and our project finance advisory work. He's your main contact for those sorts of things. So please drop an email and let him know. Following this course, I'm just about to sign off. So what I'll probably do is we're recording this. I'll hand the recording over to a colleague who will then do the clever stuff and edit it. And we'll then send you a link so that you can review it again in the future. And also, if required, drop us an email and I'll send you a copy of the model there. The model, of course, has the two sheets there, one with the if approach, and then you can compare and contrast with the mask approach. If you want a copy of that, I'd be delighted to send it to you. So just drop us a note or send something to Ben now while he's sat there still monitoring the Zoom chat window. But other than that, everyone, thank you for your attention. I hope you found it useful and look forward to seeing you on our next presentation in 2 weeks' time. So thank you very all and good afternoon.